Linear system is basically when you have two equations at the same time. Now, Sully just got done teaching you how to graph a line, so that shouldn't be an issue. That's in Algebra 2 2.4. Okay, we also can go back to Algebra 1 8.1 if you need even more help with that. But we're looking in this lesson at a system of linear equations. That means you have two or more equations at the same time. Okay, so right here you can see we have two equations at the same time. We want to solve it, which means find the pair of x and y values that will solve both the top equation and the bottom equation. Okay, so I could make up like 0, 3. Okay, what's that going to do? Well, if I plug a 0 in here for the x and I plug a 3 in here, 18 will equal 18. If I plug it in the second equation, however, you're going to get 3 plus 0 equals negative 1. Doesn't work. Okay, so we want to find the solution that will work for both. The way that we're going to do that is we're going to put all the solutions on the graph. Okay, now as you know, that's going to make a straight line, and we have to graph each one of these individually, and then we look at where they intersect. Okay, so let's start doing that. First thing you have to do is you have to solve each equation for y. So if you do that, you're going to get y equals 1/3 x plus 3 and y equals negative x minus 1. And again, we're going to go through all the techniques for solving for y that you already know. All right, so now we're going to put both of these on the graph. Let's graph the first equation, which is red. Now, if you remember, we have it in slope-intercept form. We solved it for y. And so that first number right there, we know that m equals 1/3. That's the slope. So that means we need to go up 1 and to the right 3. And we need to start at the point b is equal to 3 here. The y-intercept is 3. So you start at 3. 1, 2, 3. That's up here. And we need to go up 1 over 3. Okay, well on my graph you can't do that. So I'm going to go down 1 to the left 3. That's the same thing, right? I'd go up 1 over 3. That's the same as going down and to the left. All right, so that's going to give us the wonderful line that we see right here. All right, that's nice and straight. Let's look at the other equation. We have y equals negative x minus 1. All right, so negative x, you got to think, what number is that? Well, let's start here. B is going to equal negative 1. That's easy. That's right there. And then the slope is negative 1, which we need to put over 1. Okay, so a negative 1 on top means you need to go down 1, and we go to the right 1. All right, so we start at negative 1 there. We go down 1 and to the right 1. That's going to give us this line. Let's see what that looks like. All right, we get this line right there like that. All right, so now we can answer our question because we have the red line that represents all of the solutions to the first equation. The purple line represents all of the solutions to the second equation. And so we look at their intersection because that is the one point that's on both lines at the same time. All right, so I'm going to put that in green, and you just have to figure out what point that is. Okay, so that's 1, 2, 3. We're going back 3, so that's the point, negative 3, and then we go up 2. So we have the solution, x equals negative 3 and y equals 2. Now, if we go back, I'm going to do a little mental math here. If I plug a negative 3 in, I'm going to get a negative 3 and a 2. I'm going to get 12, and then it's going to be minus 2 times a negative 3. That's going to be 12 plus 6, and that's going to equal 18. So it works there. And down here I'm going to get, what do we get? 2 plus negative 3, that equals negative 1, so it's going to work in that equation. So that's how you check yourself to make sure you're correct. So that's basically it. That's how we do this whole section. Let's go to the next part. All right, so let's look at the different steps. We're actually going to write this down for you. Here's the steps for solving linear systems by graphing. Step 1, you're going to write both equations in slope-intercept form. That's basically your solving for y. Okay, we then find the coordinates of the point of intersection. All right, check your solution by substituting the coordinates back. We did that. And then you write your solution as a coordinate point. Remember that x goes first and y goes second every single time. Don't switch those up. That's a common mistake. Okay, so let's look at example 2 now. They're a little more difficult because we're starting to put the equations. This is called standard form, where you have x and then y, and then it's equal to a constant. Okay, so what we're going to have to do is solve both of these equations for y. Let's do that real quick right now. Let's solve both equations for y. Pause the video, solve them for y. Go. I'm going to give you, and then I'll walk you through the second one in case you're having trouble solving for y. So we get 4x plus 3y equals negative 3. Subtract 4x from each side, and then you divide by 3. You're going to get a slope of negative 4 over 3 and a y-intercept of negative 1. So let's go to the graph. We're going to start at negative 1. Remember, you start at the y-intercept, and then we use the slope to get the next point. The slope here is down 4 over 3. Okay, remember the top number's up and down, and the bottom number's left and right. And so we get down 4 and over 3. Can we fit that on the graph? Down 4 over 3, you betcha. Okay, right here. Now, I need another point up here somewhere, so we need to go back 3 up 4, back 3 up 4. That's going to put us like right here. All right, let's put a line down. Okay, so the red line is finished for us. We have a nice line there. It's nice and straight, goes through all the points. Everybody's happy. Let's look at the other example. And we'll do this one in purple because we love our purple. All right, so we're going to solve for y. That means you got to get y by itself. Of course, we're going to subtract x from each side. I can kind of do that one in my head. I'm going to get 3y equals, remember we're going to subtract x, so we get negative x plus 6. Then if I divide everything by 3, the reason why I wanted to do this one, if you look at this part right there, what is that slope going to reduce to? Here's our equation, y equals, what do we have there? It's negative x. Well, that's like a negative 1x. So I'm going to write it negative 1/3 x. Man, that is ugly. We're going to write negative 1/3 x. That isn't much better. Plus 2. All right, so the slope here is going to be negative 1/3, and the y-intercept is 2. So the top number tells you need to go down 1, and then to the right 3. We're going to start at 2, of course, so we're starting at 2, go down 1, to the right 3, and let's get our line on there. Beautiful line, and if you notice, they're going to intersect over here, very close to our last answer. We're looking at negative 3. The x-coordinate is negative 3, and the y-coordinate is 3. So we need to check those to make sure we're right. If you plug them in up here, what are we going to get? We're going to get negative 3. That's going to give us a negative 12 plus 9. Negative 12 plus 9 is negative 3, so it works in that one. And then in the second equation, we get negative 3 plus 3 times 3 is 9, so negative 3 plus 9 is 6. It works in that one. So our answer is negative 3, 3. And we're done with that example. Ladies and gentlemen, it is that simple. I cannot believe how simple this is if you know how to graph a line. Let's go to the next example. Okay, for example 3, the only difference is the domain's a little bit larger, the range is a little bit larger. We're going, instead of to 5, we're going to negative 10. The rest of it's the same. So why don't you pause the video, do this one all by yourself. Ready? Go! Pause that video. Okay, so looking at the answer here, I solved the first one. Wow, look at that. That's the red equation. That's the red line. We get negative 3/7 x plus 2. And then the second equation, very similar. We get 5/7 x minus 6. They cross, they intersect at 7, negative 1. So that's going to be our solution to this set. 7, negative 1. All right, hopefully that went well for you. Next equation, or next problem. What are we doing here? What's that fox say? Okay, the reason I gave you number 4, can you see why? I mean, why would I give you number 4? Look at it. This looks pretty routine. All right, that's not a problem. But the first equation, we have y equals 2. Okay, it's missing some stuff. Actually, that's y equals, there's no x term, so it's 0x plus 2. That's the way you can write that one. Well, what does that end up doing? Well, 0x, 0 slope. Did I ever show you this? 0 slope. If the slope is equal to 0, what kind of line is it? It is left and right. If there is no slope, it's vertical, okay? But we're not dealing with that. We're dealing with this one here. 0 slope, left and right. It's a horizontal line. Now I know why you had that line hanging out down here, Mr. Kelly. Look, the y-intercept is 2. That's right here. It's a slope of 0. You can go up 0 over 1 if you want to, but that's the line y equals 2. So I gave you this problem so that you could practice doing just a horizontal line. That's y equals 2. Let's have you solve the rest of it. Ready? Go! Pause the video. Okay, so this is what I get here. We get our y equals 2 line. That is awesome. And then for the second equation, we have negative 4x. That means you got to go down 4 to the right 1. You start at negative 2. Well, yeah, it is off the graph, so you kind of work backwards with it. You get a nice point of intersection at negative 1, 2. So let's write that down. Negative 1, 2. Make sure that negative comes out clearly. So that is our solution. If we check it to make sure it works, should we check it? Okay, that's x, that's y, so I plug it. First equation, there's no x. That's okay. Relax. Just plug in the y. Y is 2. Does 2 equal 2? Yes. Okay, we're good with that one. And for the second equation, we get negative 4 plus 2. That equals negative 2, so we're done with that one. Good enough. That is number 4. Let's move right along. Let's get through this. Okay, so I think you have enough tools now to do numbers 5 and 6. I know we have a lot of pausing of the video, but pause. Pause are on foxes. Foxes say what? Now it all relates together. That's right. Pause the video. Do 5 and 6. Go! Okay, so we're looking at number 5 now, the solution. If you subtract x from each side, the slope will equal negative 1 over 1, which means you need to go down 1 and over 1. We start at 1, so we go up to 1, we go down 1 over 1, and that's where that line comes from. The second equation, subtract 2x from each side, divide by negative 3, you're going to get positive 2/3 x minus 4. So we start at negative 4, and we need to go up 2 over 3. Okay, so that leaves us with what? We have the solution is 3, negative 2. So 3, negative 2. You can double check it here. 3 plus negative 2 is 1. That's correct. And we get 6 minus negative 6. That's plus 6. That'll give you 12. So we're good with that one. All right, number 6. Okay, number 6 you can see right here. It graphs at negative 2, 4. Okay, but the reason I show you this problem is because I want to, the reason I give you this is because I want to show you how to graph x equals negative 2 if you forget. All right, a lot of students look at that and they're totally confused. Well, here's what I always tell my students. I want you to pick 2 points where x is negative 2, okay, because that's what the equation is. X equals negative 2. So pick any 2 points. So we'll go negative 2, maybe negative 1, and negative 2, 4. All right, graph those 2 points. Negative 2, negative 1, negative 2, 4. Hey, look at that. It's that line right there. And so that's one way it can help you graph lines. It also works for like this one. Where do we go? Number 4, y equals 2. All right, so pick 2 points where y is 2. All right, so maybe 2, 2, and 4, 2. Those are 2 points where the y value is 2. So if you go to 2, 2, and 4, 2, it'll give you that line that's horizontal and goes straight across. So that is the reason why I showed you that problem there. You should get negative 2, 4 as your answer. Let's move on to the next type of question. Okay, number 7. Is 4, 1 a solution of the following systems of equations? This is so easy. All you have to do is plug this in. So the x value is 4 and the y value is 1. So we just plug it in. Is 1 equal to 3 times 4 minus 11? All right, so you're going to get, is 1 equal to 12 minus 11, or is 1 equal to 1? Yes, it is. So that's a smiley face. We're happy there. But it has to work in both. So I plug this one in here. Is 4 minus 1 equal to negative 1? No, that's not right. That's 3 equals negative 1. So this does not work in either one. It is not a solution of the system of equation here. Your answer to 7A is no. Let's try B. B, it says x equals 4. All right, so x is 4 and y is 1. So if I plug a 4 into x, you get 4 equals 4. We're good there. Okay, y is 1. So is 2 times 1 equal to 4 minus 2? We get 2 equals 2. So the answer to this one is yes. So we're done with that problem. Let's move on to the next type involving your calculator. Okay, solving the following systems using your graphing calculator. So that's going to be a big part of this lesson, using your graphing calculator. I do want to review some things first. Let's go down to the bottom. We're going to fill this in and then we'll go back up and we'll actually solve A, B, C, and D. But we can't forget, if the lines, when you're graphing these, if the lines end up parallel, then there's no solution. Okay, remember, because they don't intersect. And if the lines are the same line repeated twice, it's like the same line on top of itself. When you simplify the equation, it ends up being the same. Then we say there are infinitely many solutions because the 2 lines are on top of each other. So they intersect like lots of different times. So that being said, we're going to look at these problems. To solve them in your graphing calculator, I'm going to give you a little review real quick. Let's bring up the calculator. Okay, so we have our 84 up here. I have the key history. This is how you clear the memory, by the way. Second, memory 712. If you want to clear out all the stuff that's in the calculator, but when you do this, it resets the window. Let's hit the window button right here. Okay, by the way, pay attention to this. It's on the mastery check. You have to learn how to do this in the calculator. You can't just do it by hand. So please pass the mastery check. We already have students that get to the mastery check. They're like, I don't know how to do this. So start paying attention. Go grab a calculator right now if you need one. All right, so anyways, we hit the window button. And if you notice, we have negative 10 to 10. That's the x, and the y is negative 10 to 10. And what that means is when I look at the graph, it starts at negative 10. It goes up to negative 10. Okay, same thing for the y-axis. So that's what those values mean in the window. All right, back to the problem. Well, let's do the first problem right here. Your calculator wants the equations written in slope-intercept form, or at least solve for y. You have to get y by itself. So let's do that first. We're going to bring this calculator back so we can keep looking at it. Okay, right there. But let's solve each one of these for y. So solving A for y. It's the same that we do normally. We've been doing it since algebra. We're going to, let's bring that over here so we have room. So we have 44x plus 50y equals negative 36. Okay, what do? We need to subtract 44x. Ooh, forgot my other 4. Minus 44x. Remember that 44x and a 36, you can't combine those. So we have cancel 50y is going to equal negative 44x minus 36. All right, we then divide everything by 50, so we get y equals negative 44 over 50. Now, I could reduce that, but I'm not going to. Calculator will be okay with it. X, and then that's a negative 36, so we're going to write minus 36 over 50. All right, so there's our first equation that's solved for the second equation right here. Let's subtract x from each side. Trying to speed this up a little bit. We get minus 176, and then remember we have a negative y, so we have to divide by negative 1, and that's going to give us y equals x, positive x, because a negative over negative is positive, and a negative over negative is positive, once again, 176. All right, so back to the calculator. Here we go. We hit the y equals button. We need to put the functions in, so we're going to hit y equals. I'm going to put the first function in right here at the top, so we need to put in y equals negative 44 over 50x. So the way you put that in your calculator, y equals negative. All right, the negative button's right here. I'm going to put it in parentheses because it's a fraction. Let's get rid of this so you can see it. So negative 44 over 50. Negative 44 over 50. And then I end the parentheses. That'll end the fraction. Yes, there's a different way to do it where you can actually have the fractions over themselves, but that only works if the calculators are all updated. So I'm going to do it this way. It should work for both. Okay, the x button is right here. Okay, so negative 44 over 50x minus, and I'm going to use parentheses again like I do with all fractions, minus 36 over 50. Okay, that's the first equation. So I plug that into y1. I then hit the down, and you can tell it went in because it kind of hit enter there. And now I'm going to do the other equation. So the other one is y equals x plus, all right, so here's the x again right there, x plus 176. All right, now the reason why we want to use a calculator, we don't want to graph that. That goes way too high. When we look in our calculators, our technology is going to help us out. I notice one line, but I don't see the other line. So here's my quick fix, okay? I'm going to zoom out. So I hit the zoom button. Let's look at the window first. Here's the window. Look, we're going from negative 10 to 10. We already looked at that. I'm going to hit the zoom button, and then choice 3 is zoom out. So once you hit 3, nothing happens. You have to hit enter. So you hit enter, and it zooms out. It's like a helicopter taking off. Hit enter again. Okay, so now I've hit enter twice, and I see that they cross right here. So I need to direct the calculator to go find that point of intersection. So to do that, you need to come up here under calculate. So once you see them cross, second, calculate, and choice 5 is the intersect. All right, so it's now going to ask you, like, what is the first curve? It's going to see we're blinking on this line right here. You just hit enter. What is the second curve? It's way up here, but it's on the second line. You can tell what it is because of the equation here. Hit enter, and do you want me to take a guess? Yes, we do. So we hit enter again, and there is our first answer, negative 9482. If you need the keystrokes, what I'm going to do is show you this right here. Pause the video, and you can get all those keystrokes, okay? Let's do the next one. Okay, so choice B, you need to solve them both for y. When we do that, what are we going to get? We get y equals 4x minus 12 if we solve the top one. The bottom one, we divide everything by 2. What do we get there? Guess what? It's negative 12 plus 4x. And you know what? Those are the same equations. So we don't have to do this one. We don't have to put that in the calculator. Yeah, that's this choice right here. If the lines are the same line repeated, okay, then we write infinitely many solutions. You can write IMS if you want to. That'll speed it up. Let's do choice C. Solve C for Y. Actually, do both. Do C and D. Pause the video. Go. Okay, so here's the graph I get when I graph part C. When you solve each one for Y, you get 2x minus 10 and 2x plus 1. Okay, we put those into the Y equals, 2x minus 10, 2x plus 1. And then I hit zoom 6, because what that does is that takes me back to the standard window of negative 10 to 10. Remember how we zoomed out before? I didn't show you, but if we zoom out, okay, the window changes. You don't go from negative 10 to 10 anymore. You go from like negative 50 to positive 50. It depends. Let's do it. Zoom out, 3. Okay, I'm going to hit enter. And notice how the scale changes a little bit. If I hit the window, then it's actually negative 40 to 40. Okay, so that's what happens when you zoom out, but you want to go back and reset the calculator. You hit zoom and then the 6 button standard. That'll give you the standard window. But this is all for naught because the two lines are parallel and they are not on top of each other, so we say there is no solution. So that is part C. Let's go to the next part, D. I solved each one for y, and here's what I get. Y equals 2x minus 217. Let's put that in. 2x minus 217, and y equals negative 12/39x minus 273 over 39. Okay, so the first equation's in. The second equation, negative 12 over 39x minus, we're going to subtract 273. I always use those parentheses. 273 over 39. All right, and when I graph it, it's going to look like this. Okay, so I can't really see the other line, and again, here's where you want to zoom out. So look at the window. It's negative 10 to 10. You can do it by hand if you want, but I'm just going to hit zoom 3. You got to zoom out, and the problem students always make, they never hit enter. So hit enter. Look at the lines. There's one. Where's the other one? I'm going to hit enter again. There they go. So now you can see their point of intersection right here. Your calculator can't calculate it until it sees it on the screen here. So to calculate the intersection, second, calculate. Choice 5 is intersection, and then you hit enter 3 times. And guess what? There you go, 91, negative 35. That is it, and we're done with that one. Wow, that's a lot of stuff. We're going to try to make